In this video, I want to take some time to talk about what a covalent bond is. We've been using the shorthand that covalent bond is shared electrons. But I'd also like to give you a little bit more background to that, and particularly to relate it to a topic that you've looked at before, which is the idea of Coulombic force or Coulombic attraction or repulsion, actually. So let's see where those come into play with a covalent bond. And a covalent bond relates to Coulombic force in that force is equal to a constant times some charges divided by the distance between them. If I get a positive value for force, we call that repulsive force. And if I get a negative force, it's attractive. And in a chemical bond, we have both of them going on. We have a nucleus, right? And we have another nucleus because it's the sharing between two atoms. And so each atom brings its own nucleus. And then the space between them is where the shared electrons are. What I want you to think about then is that a covalent bond is a trade-off of forces. If I have electrons that live between them, the electrons, right, electron nucleus interactions are attractive. The electrons feel good when they are close to both of those nuclei. That is an attractive force and that is good. But the two nuclei themselves, if they get too close, repel because we get the positive force mattering. If they get too far apart, if the distance gets too great, what do you remember? Force goes to zero as distance gets big. So the atoms can be too far apart for the sharing to matter, which just means, internuclear distance. This is the space, right? D is the space between the two nuclei. So when D gets too big, the force approaches zero. As they get closer and closer together, we get a trough. And as they get super, super close, the force shoots up. And you can think about this as sort of three regions. In this region where it's basically zero, right, there's no bond because we're too far apart. In this region where we go above zero, right, this is the zero line, right, too close together. So I have what we call internuclear repulsion. The nuclei get too close, they don't like it, and so they try to find another distance. And then here in the middle, right, this is bonding. I get a negative force. I'm below zero because the electron, right, is attracted to both nuclei. And this sharing of electrons in this way is what gives covalent bonds their special properties. They're moderately strong because you've got this special bonding thing going on. It's a localized sharing where it's a trade-off between how two nuclei and their electron or electrons hang out with one another, so that the forces between molecules become as important as the forces within the molecules in some cases. But that's a covalent bond in a nutshell. It's this trade-off of attractive forces, electron liking the nuclei and spending time between them, and repulsive forces, nuclei getting too close together, and recognizing that when nuclei get too far apart, there's no bond anymore, that we have to be within a certain distance for bonding to be a thing.